Welcome to PowerShell Module 2, a brief introduction to the language. My name is Brian Cafferkey, and I'm an advanced data solutions consultant and trainer with BPC Global Solutions, LLC. I'm also a Microsoft MVP with decades of IT experience, mostly in the data solutions space. I'm the author of Pro PowerShell for Database Developers, published by Apress, also available on Amazon. And I'm a leader of two technical user groups, the SQL Pass chapter, the Rhode Island Microsoft Business Intelligence user group, and I lead the Southern New England R user group. My contact information to the right, at Brian Cafferkey, is the Twitter account, and brian256@msn.com is my email. Feel free to reach out to me, ask questions, and give me feedback on this. I appreciate the feedback. And please subscribe. This is actually a series of presentations I'm doing, and I encourage you to look back at the prior presentation to this, which is really an intro to this intro. It's something that just gives you a basic summary of what PowerShell is and the two environments in which you use PowerShell, which is the CLI, Command Line Interpreter, and the ISE, the Integrated Script Editor. So I do want to plug my book a little bit, mostly because I found when I was learning PowerShell, there was no really in-depth coverage of topics and programming in particular in PowerShell. Things tended to have very light coverage, and I think the book I wrote, which is called Pro PowerShell for Database Developers, is the most comprehensive coverage of PowerShell out there, and it really delves into all these different features and how to use them programmatically. So the presentation goals is, one is to just, if you're new to PowerShell, give you a quick review of what PowerShell is, but again I would point you to the earlier presentation, Module 1, to give you that real intro. But assuming you have some scant knowledge of PowerShell, we'll touch a little bit on what it is, and then we'll get into introducing the basic PowerShell language and constructs while we use the Integrated Script Editor. Other topics will be covered in future presentations, so again I encourage you to subscribe, and then you'll be aware of each one. And I'm trying to keep coverage into sort of small bite-sized chunks so that it's not overwhelming and you can gain one concept at a time. So this is not a comprehensive introduction to scripting, just a basic coverage of the PowerShell language and key concepts. And the scripts that are demoed in this presentation are available on my GitHub account. So it's Brian Cafferkey, or bcafferkey/shared/PowerShell/YouTube/module2. So please take a look at those. So PowerShell is a shell that was built specifically for Windows. If you're trying to get your head around what PowerShell really is, you need to kind of do a little history and remember that prior to Windows was an operating system called DOS, and that had a command prompt. And like Linux, you had to type in all commands. There was no GUI to interact with. So when Windows came along, for a long time, that was all you really had if you wanted to do programmatic scripting in the Windows environment. But it was a severely limited scripting language because it didn't understand Windows. It had no connection to .NET. Finally, Microsoft completely scrapped that and rewrote the scripting language called PowerShell for Windows. So PowerShell is the Windows scripting language, and it's also great for scripting Azure, and now it's even being ported over to Linux, so you'll be able to do PowerShell scripting in other environments. So why PowerShell? Well, I like to use this slide just to demo. Without PowerShell, you're lacking automation. So you're probably doing things the hard way, especially for administrators, but DBAs, software developers, SQL developers, it's still the same problem because you're not automating sufficiently. Or maybe you're using tools that aren't as well suited. For instance, SSIS can do a lot of things, but PowerShell can do things SSIS can't, for instance. And T-SQL, I would also say, can do certain things, but PowerShell can do more and can reach into places that are more difficult to get with PowerShell. So the bottom line is you get a lot of automation. So if you're not using PowerShell, you're probably overworking yourself and stressed, and you're like the person on the left. If you're using PowerShell, you're like the person on the right. You're carefree, and your environment is running more smoothly, and you don't even have to be there for it to be doing that. So PowerShell environments. When you use PowerShell, there's really two ways you can use it. On the left is called the Command Line Interpreter, the CLI, and that's where people get in and they just do things real quick. They get the commands done. Administrators typically will spend a lot of time there because it's very direct. On the right hand side is where you develop scripts. And then since it's a lot easier to show you scripts and demonstrate the language of PowerShell, that's where we're going to be spending most of our time today. To check what version of PowerShell you have, you can look at a built-in PowerShell variable called $PS version table, and a property off of that is called PS version. PowerShell versions have been whole numbered for the most part, so we've had 1, a 2, a 3, a 4, and a 5 version, and a 6 version, which is really geared, I think, more towards cross-platform PowerShell development. And if you want to check it again, so you can see this, I would recommend you try to be up to the latest version you can be. If you're running Windows 10, you're probably all set because you should be at least at 5.0 out of the box. But if you're using earlier versions of Windows, you want to check this, and you can install, go on Google it, and you can install upgrades and newer versions of PowerShell. It relates to the .NET framework also, so when you do upgrade PowerShell, you'll also be upgrading the .NET framework. Now, by default, running scripts is not allowed in PowerShell in most cases, depending on various settings and things and versions of PowerShell. So to turn it on, you need to start the Windows console as administrator, as shown here. So you'd right mouse click on Windows PowerShell, run as administrator. After doing that, then you should have the permissions necessary to execute the commandlet you see here, which is set-execution policy. And the option it's being set to here is remote signed, which means local scripts, anything written locally, can be executed with no problem, but externally written scripts that are downloaded need to be signed, which is a pretty good middle ground for security. Now again, I would say go back to my prior presentation on the CLI and the ISE if you want a more detailed walkthrough of turning on the scripting in case you have any problems there. Now to start the PowerShell environments, prior to Windows 10, you would look under Accessories and you'll see a Windows PowerShell folder with the programs. Under Windows 10, you just go to the Windows PowerShell folder and you'll see two types of programs often. You'll see the, in parentheses, x86. Those are 32-bit versions of the program. And you'll also see ones that don't have that, and you'll see some that said ISE, which is the Integrated Script Editor, and ones without the ISE, that's the command line interpreter. So let's take a look at PowerShell syntax, and I'm going to do some demos, but I want to look at the syntax with slides with all these call-out boxes to kind of get a smattering and a feel for the PowerShell language. Now one of the things that's really useful in a scripting language, or any language really, is to be able to put comments in to document what the code is doing. And multi-line comments can be accomplished in PowerShell by starting the comment block with a left caret and then a hashtag or pound sign, and then as many lines that will be ignored by PowerShell. That's what comment lines are, they're ignored. And it can be ended by the hashtag greater than sign. So that marks off. So the lines here, the script name, SCR basic, the purpose line, that's all ignored. PowerShell will skip over that in the script. Then you see the next slide says clear-host. Now that's a very important thing to see and understand because what clear-host is a commandlet. You usually see that spelled as CMD-LET. And commandlets are really PowerShell commands, statements. They follow the format of a verb-noun, and the verbs are important because they help you understand what the commandlet is trying to do, what it does. Here, clear means it's going to be clearing something out, right? It's going to be emptying something. But there are other ones that are like new, for creating new objects, and all these different things. And then the object can be any number of things. So the noun side can really, as there are many different things in the world, the noun can be almost anything. You'll notice a little pound sign halfway into that line, and then it's to clear the console screen, and that's an inline comment. So when you want a single line or inline comment, you can just use the pound sign. Anything after the pound sign on a line is ignored. The next line says $myobj equals, in quotes, Brian. And what that's doing is it's creating a new variable, or really an object, and it's putting the string Brian into it. Notice that we're not declaring a type. We're just putting something in a variable, and we don't even have to pre-declare the variable. That's very similar to things like Python and JavaScript, where you don't have to predefine variables and they don't have a type. However, the next line is kind of interesting because what we're doing there is we're defining the type being an integer, and then we're saying it's $myAge, and all variables start with a $. That's how we know they're variables, equals 33. When I do declare the type, when you put that in brackets before it, it's strongly typed. And like C# or Java or C, when a strongly typed variable will be enforced. So if somebody were to try to put a string, like the word Brian, into $myAge, you'll get an error in PowerShell, kick back and not allow that. Whereas the myObj, because it's not strongly typed, it's just an object, it will let you put anything you want in it. So it's optionally strongly typed, which is a nice feature. The other thing that you'll notice is the line that says $myobj.substring. There are automatic methods and properties created for the objects that we create in PowerShell. So when we create variables, they're not just simple variables like anything like a Java object or C#. They have methods and properties automatically created in part of them. And some of the useful ones, like substring, allows me to get pieces of the string in the object. The last line shows a string on a line by itself. Now any variable or string like this on a line will automatically be written to the console. And we see in the double quotes, hi, and then $myobj. That myobj, $myobj, that's going to be replaced by the value of the string or the object. So it's going to say, hi, Brian. Then it says tick mark, right, the little tilde. Tick mark, my age is a nice age. Because of that little tick mark, which is just above the tab on my keyboard, it's not going to replace the variable myAge with the value 33. It's actually going to just literally print out $myAge. So that's a nice way. It's called an escape, and that's a way of telling PowerShell you don't want it to do this variable replacement. Now, one of the things I really like about PowerShell is the way it handles strings with these double quotes is I can put variables in line anywhere I want. The $sign tells PowerShell it's a variable, so it's not confusing to PowerShell. And it will expand the variables as desired, as shown here. But notice how easy it was to suppress that expansion. All right, let's go on to the next piece. I want to go to do some demonstrations here. So let's step out of the slideshow. I'm sure we all enjoy those very much. And as I mentioned, down in the console, down here, we can do something like this. And notice that in the ISE we get IntelliSense. So as I type, it's trying to figure out help me do what I need to do, figure out what I want to do. And I want get child item, and I can press the tab to select it. Get child item is like the dir command, and I can just do that to see what's listing in my current folder where I'm located. And PowerShell does have that concept of your current working folder. All right, so the console, we can do many things in the console. Pretty much any commands we can enter in PowerShell can be done in the console. Thing to note about this is above we see the script. This is really a console integrated with a script editor, and that's pretty much what any integrated development environment really is. It's kind of helping you integrate what you're developing in your scripts with the console. And so that's what's happening here. If you use Python or R, you have a similar type of thing. Now we do want to check our PowerShell version, and we can do that by using the built-in variable $PS version, and notice the IntelliSense is helping us, PS version table. And if I hit enter by itself, I get a whole bunch of different attributes associated with that. Sort of name value pairs. And the one I'm interested in is this one. So if I want to just get that one, and in the console I can push up arrow to get my last statement, I can do period, and now I see all the properties and methods available. And what I want is the PS version. So I hit enter, and you can see here it's giving me back my version, which is 5.1. So again, it's a good idea to check that. You may look a little different if you're running on a prior version to Windows 3, PowerShell 3. You may not see this little window to the right because that's part of the ISE that came, I believe, in 3.0 or later. So I do want to also call attention to that. It's kind of a handy little thing. I can do things in there like get and say something, my command like get child item, and double click on it and say show details, and that allows me to it has a little wizard there, lets me walk through building commands. And in this integrated script editor, I have a file menu, an edit menu, and things you would typically expect to see. If I want to tailor the environment, I can use tools options and set things I like there. A bunch of different things I can do. I also have a toolbar, and I tend to stick with the toolbar mostly because it's just a handy way to get to what I want to do. All right, so let's take a look at the script. This is almost the same as the script in the slide, but slightly different. So as I mentioned, where we have this is block comment. So my comment starts here. It says ignore all the things that I have until it reaches a pound greater than sign. So if I were to run this, it will appear in the console as it does here. But notice it's not doing anything. It's just displaying it. So the scripts tend to echo back to you in the console. But they don't always do things until you tell it to do something. So I'm going to clear the console for a minute. And I can use a shortcut or alias for clear screen or clear host, CLS. And I'm going to, in here, create a variable myobj, as we saw, equals the string Brian. And by putting the variable on a line by itself, it's going to display the value of the variable back to us. And we can see that it did that right here. And then I'm going to create an integer, int myAge equal 33, $myAge. And notice it doesn't really show us anything other than echoing back the statement. But look what happens if I try to assign something that is not an integer to that variable. And it's telling us it cannot convert test to system type int32. So it can't, not the right data type, so it doesn't like it. Now interestingly, if I put in quotes, which means it's a string, but I put in quotes something that could be converted to an integer, PowerShell will convert it to an integer. And I can display it just by highlighting in my code. I can highlight the variable and display it, and there it is. And if I want to confirm that it didn't go and change the internal type to match what I entered, I can use the method getType and then the property of the method name to show me that it's still an int32. So it did convert that 25. So PowerShell can be pretty helpful when it wants to be, and that's one of those cases where it tries to figure out what you really want to do and does things for you. And notice that I also have a method, which we saw, and we're going to do substring. So we're going to take the string Brian, and we're going to ask for the first 3 characters of it. And we can see that it came up there. And again, there's so many methods and properties that it's really useful. Let me just show this again so I can say myobj. If I put a period, I can get the length from it. I can clone it. I can do copies, contains. I can compare. I can convert data types with this. So there's a lot of nice string functionality and object functionality built in. I just created it, and it gave me all these nice methods and properties right off the bat. It's a good idea to try to use those. You can search for commandlets that will accomplish the same thing, but why do that if it's already got something right off the object? And I think that may be kind of something people overlook that are new to PowerShell, especially something I took getting used to realize, wow, there's stuff right on the object that I can leverage as opposed to trying to find commandlets out there. All right, now we saw this in the slide, and what we're going to do here, in fact, I'll highlight also the comment to show that it really has no effect, the expand variables comment. And let's see what happens when we run that line. Okay, I have a line on itself, so let me rerun this. And we get back is hi Brian, because my obj was replaced with the value, but $myAge was not, because it has that little tick mark next to it, which is an escape. So it doesn't replace it. Now, if you really don't want variable expansion at all, you want PowerShell to print or assign exactly what you ask it to, use single quotes as opposed to double quotes, and PowerShell automatically does not do any variable expansion. So you can see here, single quotes means it just leaves it as is. Let's take a look at another script. Here we're going to do $myArray, and we're going to assign it a list of 10 numbers. So we're just creating an array on the fly. Now, because this is PowerShell, it's not really a numeric array, it's a collection. And we haven't strongly typed it, so it's really truly an object collection that just happens to have, and I'll highlight the number here, just happens to have a list of 10 numbers. We can see that here. I'm going to create an integer strongly typed, and I'm going to assign $sum, and I'm going to assign the value 0 to initialize it. And notice we can put semicolons at the end of lines. It's not required. It may be a best practice, especially if Microsoft sometimes stops enforcing that, but currently it's not required. Now, what I want to do is, my array is a collection. As we've seen, it's a list of 10 numbers. So the idea here is I want to create a loop. So this is a loop. And what I want to do is say, for each element in my array, take that element value and put it into the variable, which is dynamically created, by the way, $val. Now that you've done that, do this code that's in the block, between the braces, which is going to write host right to the console, index with value, and since the $val is in this double-quoted string, it's going to expand it as we saw, and then take $sum and add the value of $val to it, so increment it by $value. And what's going to happen here is this will iterate over the collection, so it'll keep pulling out. First it will start with 1, do the code, then 2, do the code, all the way through 10. And finally it will end here and say, write the sum out. So I'm just going to run that one block to see what it does. And let me clear the screen quickly down below just to make it a little bit easier to read. So I'll start with my array, the initialization, and the write. We can see that it started with each value. So this is the write host statement we see here. It does the addition of the $val to the sum, so it's totaling. And it keeps doing that, but it doesn't display it until it gets to the right host. And so we see that here. We can see the sum is, and it puts the sum, again, embedded within the string. It just expands it. So it's pretty handy. So the for each, interestingly enough, the for each is not a commandlet, it's a command. And there aren't too many of those in PowerShell, but that's one of them. And what it does is, again, it's designed to pull out elements from a collection and allow you to iterate over them. It takes the collection as a parameter. Now I did want to talk about if conditionals because you always have ifs in programming. So what I want to demonstrate here is, now remember, the variables and objects stay in memory. They're not going anywhere until you tell it to. So if I look at $sum, I can see it still has the value of 55. So I'm going to do a little comparison. It's not a very useful one per se, but just to demonstrate how we do conditionals. We're going to say if, and I want to point out a few things here. One is the if must have its criteria in parentheses. It's not an option, and if you don't include parentheses, you'll get errors, so be cautious of that. The other thing is the comparison operator is not the typical one you'd expect to see. In C#, it might be equal equal. In other language, maybe just if sum equal, like VB. Here it's a mnemonic with a dash. Now frankly, this is a very difficult to get used to convention because it's very unusual. So I'm going to point it out. I still make errors with it, and I want to highlight that as much as possible. If you're having any kind of trouble with comparisons, check this. That's 90% of the time probably what the problem is. You're probably trying to do something like if sum is greater than instead of the dash GT. All right, so let's run this code, and what I expect to happen is, since I know $sum is 55, I expect to see the message, wow, that's a big number, be printed to the console, and I can see here it did. Nice. Now the other thing we may want to do though is, so maybe we want to do a comparison, sum is greater than 40 or something, and we want to do something else, and some other condition. So here we're going to do a condition where we're saying if $sum is greater than 40 and my array is greater than 6, then print this message. Now here's a little thing. Just like the comparison operators, the logical connectors or an AND also have to have a dash. Again, this is not intuitive. It's not an easy thing to get used to, so I'm going to hammer that away as much as I can because it's one of the most difficult things I found getting used to PowerShell. But once you see it and you realize what the problem is, you can correct it easily. So let's run the code. And let me clear out the console first. I'm going to run this code. And before I do, let me highlight this for a minute. We know that the sum is greater than 40. It's 55, I believe. And we know that my array count, we can run it and say, what is my array count? And it's 10, right? We can see. So we expect this message to print. So let's run the block of code. It's not printing what we thought. It's saying condition not met. That's kind of weird. It means something's wrong in our code or something, or we're doing something wrong. Well, one of the things we can do in PowerShell to try to figure out what it is first let's test our first condition. I'm just going to run that block, sum greater than 40. And it's saying true, so I know that's okay. What about my array count is greater than 6? I'm not getting anything back. I'm trying to pause and I'm trying to push you guys to look at this as we go through this. Why might that not be working? I know you're new to PowerShell, but I've just said some things. And the reason I'm highlighting this is because in my own preparations for this, I made an error, and this is it. And I had to take a minute to back up and think, why is it not working? So why do you think this might not be working? Can you think of any reason in the code? Okay. It turns out it's this. Remember I said you can't use mathematical operators. That's not valid in PowerShell. And worse, PowerShell didn't even give you an error. So you got two problems there. Notice PowerShell didn't complain. That would have been nice. It didn't. What I need to say here is -GT. Now it's good. And now if I run the block of code, I should get what I expect. Greater than 40, and the count's more than 6. So that was really meant, I did that on purpose to sort of call attention to that oddity and really emphasize this whole mnemonics thing. It works fine and everything. It's just an unusual coding convention to me. Now, I also want to point out something else, which is a couple of things together, which is piping, and something other than for each, which is the for each object. Now, you have to be a little bit careful in PowerShell with this because there is a for each statement, which is just for each, which we see up here. And that for each, sometimes short names like for each are really just aliases, which are short names for a commandlet. So for each could mean it's an alias for each dash object. And depending on how you code, that's what it will do. It will translate to the for each object. But there is a difference between for each itself and the for each object. I'm going to cut and paste this down below so we can see them side by side. And what you'll see is that the for each statement, which is not the for each object, takes in the myArray as a variable parameter. So it's actually passing the collection in. Whereas the for each object takes in a pipe. And what's happening here is, if you remember, myArray is a list of numbers, correct? So we can see down here that it's a list of numbers. And the pipe operator says push this in, stream in this list of numbers, stream in this data, one row at a time, into for each object. Now, some commandlets, many, most, are what you call piping aware. They expect to be able to get things sort of pushed into them like this, and so they can support it in their programming. And the for each object commandlet is one such commandlet. And so what you can do with that is now iterate over each element. And here's the little interesting thing. $_ is sort of an automatic replacement as each row is piped in. It's a little like what's happening here, but the difference is instead of passing the collection in as an object, I'm piping it in, I'm streaming it in. As a result, I don't assign a name like I did here. PowerShell has a default name it gives it, which is $_. Now, if I try to look at $_ by itself, it doesn't give me anything. It doesn't exist yet. It's a dynamically created variable. And it will contain each element or each row of what's being streamed, the pipeline. So if I run this, I get something similar to what I got in the other block of code. It's looping through. It's saying my value equal 1, my value equal 2. So it's iterating through. And each time it's doing that, it's using the $_ to get the 1, to get the 2, to get the 3. It's streaming the pipeline through. This is a really great way to do something that can be more efficient, I believe, than the other method, because here I'm passing in the actual array, which might be really large, and I'm passing it as one big block. Here I'm streaming it in more. I'm pushing it in. So I think there's some efficiencies to be gained by doing that. But the main thing I want to point out is there's a difference between for each and for each object. But the odd thing is, if I were to take this out, the for each object piece, it will now know to translate for each into for each dash object because I'm piping into it. I'm going to say that again because it's confusing. And you may hit a problem. This is why I said this, because I found in my own code I was surprised it was behaving so strangely. But we have aliases in PowerShell. An alias is, and I will show you for instance, if I look at dir alias, I can see all these different short names that are mapped to other commandlets. Basically, it's a way of saving us typing. So for instance, if I look here, I can see that I can type in dir instead of getChildItem. And that's a really handy thing when I'm interactively coding in particular, because I can do dir instead of getChildItem. Now for each is an interesting one, because if I look here, I'll find that here. Okay. By the way, the console has an annoying habit of you trying to highlight something, and the first time you try it, it always jumps back to the command prompt, and the second time it does not. It's a very strange glitch, but I did want to point this out here. So you can see here, for each is mapped to for each object. Here's the weird thing though, it doesn't always do it. If you code like this, for each does not turn into this. But if I were to do this, then it should map that to the for each object anyway. And so notice it still works. And that's the interesting thing to it. However, and I'll prove my point here, if I were to say for each object here and try to iterate, I'll get an error. Doesn't like it. So the point of all this is just being aware, and I belabored this a bit, but it's a bit of an oddity, and if you do deal with for each, you may hit it. So I'm going to leave it at that. We've covered a lot of good stuff here. Let's go back to our slides. Okay, so we took a look at creating variables, and there's a whole list here of all the different data types you can create, different variable types. The really more important basic ones we'd probably use is things like the array we saw, bool for a logical variable, date time for date time, going to jump down, int32 and int for integers. The single and float are for decimal type numbers, string for just a string variable. And those are probably the most common. A switch is really used only for parameters really into functions. That's the bit. And there's a link below that you can use if you want to go follow this up, because I just really cut and pasted this from that link, which is a very useful one. So to kind of talk a little more about PowerShell commandlets. If we remember what I was talking about before, how we saw those, I mentioned they always have a naming convention of a verb-noun, and the verbs must be selected from Microsoft's approved list of verbs. The noun has more flexibility in terms of its naming, because obviously there's so many different nouns out there and not a lot of consistency in what an object can be. But the verbs are really key because they give you a sense of the action that the commandlet performs. And you can use the commandlet get-verb to get a list of the approved verbs. And we also looked at the fact that variables are objects with properties and methods in their own right. And we saw that the IntelliSense will actually pop up a list of what those properties and methods are for us, which is really nice. And then we should try to leverage those whenever possible. We also noticed, and I really kind of hammered away on this, that the mathematical operators for comparison do not work, and that we have these dash mnemonic types of operators like dash EQ and dash NE. And it may seem very straightforward. You look at code, you say, oh, that's easy. But it's not intuitive. If you've used other programming languages, it kind of throws you. So again, I try to hammer away on that and emphasize that. Remember, I used the greater than sign and it wouldn't work. And logical operators also have this. We have mnemonics dash and dash or. And I think those are even similar, easier to sort of get wrong, because you may be used to ampersands or other things in the fact, or just doing an and without the dash. So a quick review of what we just discussed. We did a discussion of what PowerShell is. And after talking about that, and we learned that it's basically a scripting language, a language for automation of Windows and Azure and now cross-platform automation. Then we stepped in and we looked at demonstrations. I discussed the PowerShell language, kind of covered its syntax, and then did a couple of scripts demonstrating the PowerShell language, its syntax, commandlets, and piping. Now this was very basic. And we did also cover a little bit about the integrated script editor and how to create scripts. But again, the first presentation I did covers that in better detail. So this was a very basic presentation. I hope you liked it. And give me comments and feedback. Please subscribe, because I'm going to be doing more of these. And I'm really going to take the approach of trying to take small chunks at a time, because I find it's easy to digest for our minds, just as it would be our bodies, when we get small chunks as opposed to a lot at once. Thank you.